Hello reviewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about VisionFive 2 or RISC-V's current S single board computer. So let's dive right into it. Now, before we understand the single board, we have to understand RISC-V itself. Now, this puppy is a new kid in town that is trying to beat the giants. Now, which are the giants? We have x86 in one side, Intel and AMD, and we have ARMS in ARM Limited. Now, ARMS generally sell their design, core patented design to everybody who's willing to pay for it. For example, Samsung pays for it, they built Escanos using that. Qualcomm pays for it, they built Snapdragon using it. So that's the whole point. That's why ARM has like never seen as like, oh, I have ARM processor. You always say Snapdragon processor or Mali processor, whatever have you, because again they license out the core design. They are the core holder of that ISA. Now all of these ISA, they are awesome, they do work. There are some other ISA, for example IBM has their PowerPC ISA, many weapons contractors, they have their own ISA, but in common day-to-day use, these two ISAs are the king, and RISC-V is trying to beat both of them up. Now the idea behind that is they are open source, meaning RISC-V has the luxury of like everybody working on it, and no matter how smart you are, no matter how many people you have, you still have limited number of people like in ARM and in x86. But if basically RISC-V becomes a big thing, so many more people will be working on the core level, instruction set architecture level of it, that it will be really robust, reliable, up to date, latest. So lot of people are pouring their money into it, and I mean some people with some really deep pockets. Global support is there, and current market is poised for takeover. Why? Well, x86 is old. What does that mean? That simply means there are many quote-unquote legacy support that they have to build into the code that is inherently making it sluggish. And you must have noticed that Intel did try to make a smartphone system on chip long ago, and it backfired horribly. They could not do it. And recently you must have noticed that Apple jumped from Intel to basically, RISC system. They went to ARM. ARM is a RISC system, and x86 is 6 complex instruction set architecture. RISC is reduced instruction set architecture. So in Apple did that. Now be mindful, Apple did not jump from Intel to AMD, it jumped directly from x86 to ARM. Now x86 has reached a point where its previous legacy itself is holding it back. Too many things is there, and inherently it's not that amazing as it used to be. Like back in the day when it came out, it changed the whole thing. That's why it's the granddaddy at this point in time, but it's showing its age where it's like, bro, too much legacy. Then you come to ARM. Now ARM is good and all that, but again you still have to pay a lot, and not to mention ARM holding lost a majority of their trust the moment the announcement was made that Nvidia was trying to buy it, and the fact that ARM was willing to do it. It was not like, ARM is like, hey, I'm cool, and then randomly somebody threw money and it's like ARM is like, dude, why the hell I will sell? No, ARM is like, I want to sell. There was like freaking court battle around it. So you have to understand that puts some serious doubt, meaning ARM is not in a good healthy situation. Again, nobody knows what exactly is that, but again, companies are never sold if they are completely healthy and awesome. YouTube was sold to Google because again YouTube was losing money. So that's always the case. Like you do not sell, oh, I'm making billions of dollars, I'm gonna sell it for billions of dollars. Generally people don't do that. So that shook up what you call faith in the industry, that ARM is not as stable as they thought, and x86 again not as awesome as people thought. So market is ready and ready to go. And then the trade wars happen. Now trade war is really awesome simply because once you create a trade war, you can starve a country. Now if you starve a country, what other things then still work? Open source, meaning you can starve Microsoft, remove Microsoft from basically Russia, but you can't remove Linux from Russia. So that's the whole point. Open source love this sort of conflict environment because everybody has to work on it and everybody else benefits from each other work. So it becomes a global currency, so to say, where again people love it. It's open source, everybody is working on it. And most nations at this point in time wants freedom. Freedom cannot be had like, oh, we are free. Yes, deal. Who is paying you for your chips? Like how badly Russia got stuck. Like it has to buy things from Iran. Let that sink in. It has to buy things from Iran, which again, it's also sanctioned, so they do not have weapons grade microchip access. So they're building microchips literally by salvaging it from modern IoT devices. Not even joking. Like their weapons grade hardware, it's literally stripped down refrigerator, sometimes a washing machine and all that jazz. Like you can check out the ICs that people have captured in Ukraine. It's like, dude, this IC is for this. So that's why independence is one of those things that 2020 taught the whole world. We are not that independent as we want. That's why everybody wants that, this silicon thing. And RISC-V is like the only tool that we have. And be mindful, you cannot make ISA on your own. You can do that for weapons projects, generally it is done, but that's a very specific, very niche case. But when you are talking about making a general purpose computer, that can't work simply because you have to write everything and you have to build everything else also. For example, RAMs, for SSDs, all the algorithms, all the protocols, all those things. And that is flat out undoable. Like even IBM cannot do it. That's why PowerPC is limited to their lineup. So we come to this SBC, single board computer. Now, to reach public, be mindful, this RISC-V is slowly gaining market thrust, and at this point in time, there are chips that you may be using in your day-to-day life that has RISC-V, but to reach operating system level, whether either Android, whether it's iOS, whether it's basically Microsoft or Linux, it has to reach what we call operating system level. It has not reached there. It is like almost microcontroller. It's almost like Arduino layer. We need to make sure it reaches Raspberry Pi layer. Now VisionFive 1 was already released. It was a starter kit, and this is a Mark II of that same ideology. And this is far more powerful as system on chip with better I/O. And it does have one very interesting thing: dual gigabit Ethernet, which is rarely seen. But I think the core reason is for that. This board is supposed to showcase what RISC-V can do. There is one very growing market, that is routers. Now, back in the days, routers were not that important because our internet speeds is going YOLO. I mean, like even I have like a very slow internet of 300 Mbps up and down with 3.2 terabytes of capacity. Bandwidth cap. Router is becoming a thing where it's like you need horsepower in routers. So having this sort of two port allows this SoC to shine as a router. So if some developers look at it and they're like, if I want to do this with Raspberry Pi, again, Raspberry Pi has more horsepower, more polished system. I have to build a whole different board, whole different PCB in order to do that. Here, it's just like people will experiment with it. And that experiment, if 10, 20 people experiment on it, randomly magic things can happen. So this was a very clever move. They have up to 8 GB of RAM, which is good enough for today's time. 2 USB 3.0, 2 USB 2.0. Now be mindful, back in the day they had 4 USB 3.0, but point is, I don't think the SoC actually has enough throughput where you can just run all 4 at max capacity. So they removed it. eSMC sockets have been given, like basically it's better SD card that you can put and forget about it. The SoC is JH7110. It's a 64-bit quad-core CPU, and it does have NVMe support because again, SATA SSDs have already fizzled out. So people are going to NVMe, and it has NVMe support natively. Be mindful, you can't directly boot from it at this point in time. They are working on it, and then it will be supported. Like again, the hardware is there. It's just that they are working on it to finalize the system. It does not have inbuilt Wi-Fi or Bluetooth. I think that was compromised for these puppy. But again, they will give you a dongle. It's many people who are getting the starter kit, they are getting the dongle itself. It does support PoE hat, which again helps me to think that they are really serious about using this as a router. Be mindful, the PoE hat is from Raspberry Pi. It's pin compatible, so you can just buy a Raspberry Pi PoE hat, plonk it on here, and voila. So this is the SoC. Nothing that major, like it's not like whoa, it's like okay, it's a different SoC. Mark 1 again, the same thing. Putting horsepower on a board is child's play. Making an ecosystem around it that works, that's the hard part. And they are also struggling. Again, that's why they are releasing so quickly. 1, barely got it running. 2, much better. But they need 3, 4, 5, 6 where it becomes a everyday kind of tool. So why they are doing it? Well, you have to understand, flat out, it's not meant for general Pi audience. Meaning, if you are expecting a normal Raspberry Pi kind of experience, this is not it. This is not for you. It's not even targeting you. The idea is, as this basically RISC-V operating system, ecosystem, is a very early stage. It's basically where Raspberry Pi was 10 years ago. Raspberry Pi is old at this point in time. So 10 years ago, Raspberry Pi was barely working, barely. I remember reading articles about it. It was a barely competent thing. But again, people kept working at it for 10 years. Now we have a system which is like almost a full-fledged computer. So RISC-V also needs to go through the same process. They cannot be like, okay, somebody in the lab figured it out. That's not going to happen. They have to have an ecosystem. They have to sell the hardware to enough people. Enough people have to experiment on it. Then only the cycle can continue. It's like chicken and egg scenario. It's like you can't make a polished hardware unless the hardware goes to the people. And again, people will not buy the hardware if it's not polished. So chicken and egg scenario. So somebody has to take the bullet. So they are like, okay, let's just flood the market with the board. So drivers and kernels, they are still in working process. They do work, but sometimes people have odd issues, and sometimes people only do this flat out not working. So be mindful. That's why I said it's not targeted for basic audience. And they are trying to do, why they are selling it? Basically, they are trying to build a healthy community. Because again, Raspberry Pi reached a point where it's like, okay, boring thing. And there are a lot of people who are like, they require stimulation, they require challenge. An awesome challenge with awesome namesake. And not to mention, it does have the ability to go down to deep into ISA layer, which again is opaque in case of Raspberry Pi because again, they buy it from ARM. So they are trying to do it, and that will allow them to boost operating system development and polish it. And RISC-V needs that smart people. If you are smart people, go into this. This is a very good show off. And again, even as a someone who's developing operating systems, you can show this in your portfolio as like, dude, what you work on. Like many programmers and kernel level developers, they do work on these sort of projects on side. Like, how do you think we have so many operating system for network attached storage? Somebody did it on side. So same thing goes here. Like you can be like, hey, I work on RISC-V. That's a very good selling point in your, portfolio, so to say. It's like, have you worked on something important? Oh yeah, I just created this fork. This was the issue with RISC-V system. I've solved it. Awesome. That's why they are trying to get this happening, not from their end, but from public's end on their own. Smart people has to come in first. So what about community? Community is the key here, because computers have way too many layers. This is just a basic graph. Basically, you have application, which you and I interact with. Then you have algorithm that is working behind the scene. Then you have programming language, which people somewhat understand. Then we have assembly language, God help you. Then we have machine code, really help you. And then we come to ISA, instruction set architecture. This even Apple cannot touch. Be mindful, Apple M1 is not ISA independent. It is still ARM's ISA. Then we come to microarchitecture. This is what ARM's Holding actually develops and sells to other people. Then you have gates and register. This is what Samsung and TSMC, they develop. And then you have transistors, like actual chips, not chip, transistor, like N junction, P junction. And then you have physics layer, because again, you cannot just design whatever you want. It's like etching process cannot etch it reliably. They're like, no. So ask Intel, they are stuck here. Like that's why they did not jump as quickly as they wanted to. They got stuck in 10 nanometer. Physics layer was not cooperating with them. And all of these layers, it's so complex nowadays that no single entity can work on it. Back in the days, it was possible that, somebody in paper and pencil can draw a computer. And that's how literally first Apple computers were made. But today it cannot happen. Like we are no longer in 1970s or 80s. We are into 2020. So computers horsepower is exponentially far more. To give you a context, like what kind of complexity we are talking about, there is not a single human that can design modern processor. Like not even a single human. So like who the hell designs it? Nobody. We literally have algorithms that designs nodes. Those nodes are gone into through basically feedback loop. That feedback loop creates a bigger architecture. That architecture, people hope that it works. Then they send it to fabrication lab. Then it comes out. And if you ever wondered why the heck modern CPU have so many backdoors, this issue, that issue, that's why no human is designing it. No human can be like smart enough where they can like, there is 6 billion transistor. Like think of it, just 6 billion plus connections. Do you really think a human mind can do it? No, flat out can't. So it has to be done by computer. Basically, we are building computer algorithm that is building the next generation algorithm. That algorithm is creating the CPU. So, and that's why these things are not reverse engineerable. Like China tried pouring money like there is no tomorrow. Soviet Union to Russia, both of them poured money like there is no tomorrow. It is non-reversible. Like unless you know the codes, and not to mention the whole architecture from A to B, A to Z, you simply can't. So this is one thing you have to understand. No company, even if Samsung, even if Apple, none of them can take care of all of these layers. And if you do not have all of these layers aligned, perfectly working, you will not have the polish. So this is one absolute reality of it. RISC-V, again, it does have some benefits. Like if they can take care of upper layers and they can take care of the lower layers of ISA layer, that gives them the ability that they can truly become the next big thing if these layers are worked on properly. So Pi is successful simply because of ecosystem. There are so many companies that made Pi clones, so many, but all of them failed for one simple reason: no ecosystem. And that's why I said chicken and egg scenario. Nobody's gonna buy a hardware if it's not polished. Nobody's gonna basically polish the hardware if it's not sold. So those two things, somebody has to take the bullet. Like Pi was the first people who took the bullet. They're like, okay, we'll just launch it. Let's see what happens. It took off and voila. And all other companies, they could have actually succeeded, but they were so much focused on making a spec sheet bump where it's like, oh, this has 2 USB 3, we'll give 4 USB 3. It's like, bro, do you give the operating system with it or not? And that part is like, nah, just at launch, they give it no polish, no after work, no driver refinements, nothing like that. And they're like, it fizzles out. That's the reason. So RISC-V needs that whole huge ecosystem. Be mindful, this puppy is going into microcontroller. RISC-V is coming from microcontroller. Like there is like RISC-V microcontroller ecosystem already reached your household at this point in time, 2023. So community is very important. That's why that single board computer is being worked on. This will allow them to take care of multiple of these layers at the same time. Then we come to the race, the current race. This is the most important Cold War going on at this point in time. And yes, I am aware of there is a Putin going YOLO on basically Ukraine and Ukrainian bitch slapping Putin. And do not say Russia as well. No. Dude, from 1 year you fail to decapitate the government, 1 year you fail to freaking have air superiority, and it's like one of the, oh, they can do this and that. It's no, you can't. Flat out can't. Like, you lost majority of your army. You have to do flat out what we call Call of Duty. That's just not acceptable. Like, you can keep fighting. They did the same thing with the Afghan war. Did not end well. So it's one of those things that's like, no. Even with that going on, this is a very important war game. Why? It is directly proportional to intellectual property, fabrication capacities, and future of a nation. For example, what happened to Cuba? When was the last time you heard about Cuba? It was like, not in movies. I'm talking like, oh, Cuba is this, Cuba is doing this. When was the last time you heard about Taiwan that is doing this? Like, Taiwan had a flood and a hard drive factory got flooded. Every Tom, Dick, and Harry in the planet started to know it. That's the power. You have to understand, if we control these puppy, it matters. If we do not control these puppy, your country may be independent, but you are 100% dependent on others. And 2020 bit slapped the whole world into waking up. A lot of American businessmen sold their country, and consequence was that America literally going from building the ISP to we are dependent on China. It's like, how the heck that happened? But again, businessmen only care about moolah. So that does happen. So everybody is pouring their money into it. And again, China is also important because again, they poured $10 billion for years. It's not just like, oh, 10 billion out of my pocket. No, for years they have poured away because they wanted silicon technology. They could not get it. Again, corruption was a primary reason. On top of that, you may be like, hey, why can't just they have an electron microscope etch through multiple PCBs and just like go through it? You can't recreate it. And it's generally said that each processor's actual data that goes into the machine, that SLA machines, basically lithographic machines, they could be a few terabytes. One processor is, again, billions of transistor and calculations. So it's like, it's actually kind of small. So Russia and China, both of them are, and this is Russia's chip that they are developing with RISC-V, and this is China's chip. And be mindful, there are many chips already in use. I have linked the videos down below. So they are pouring money on it like there is not. Like, why the heck they can't develop their own? Same problem. If you develop your language, if nobody else uses it, there is no point. So they had to accept it. It's a like bitter defeat kind of thing. It's like, okay, we get it. We can't develop our own. We burnt enough money. It's not going to work. Let's just use open source. At least we have the benefit that we can go down to core level. We do not have like, oh, there is like, backdoor, Russian backdoor, American backdoor, Chinese backdoor. There is no backdoor. You can go down to the deep level. So they are doing it. And again, West is also getting benefit because again, Western intelligence can just look at it and figure it out. It's like, oh, they did this. This is awesome. Oh, this is not wise. This is not smart. They can learn and they can improve. So everybody will improve because of that. And private players. This is a, government level. I'm talking about private layer. For example, this puppy. Now this puppy is important. Why? This is from Western Digital. And here's the interesting part. There is a good chance if you have Western Digital product, some of the products are already using this. What does that mean? That simply means Western Digital buys their NAND flash from other companies. There are many companies that make it. Awesome. But you see, how do you take NAND flash and make it into NVMe SSD? To go from NAND flash to NVMe SSD, you need a controller. And your speed, performance, efficiency, reliability, longevity, everything is controlled by the controller. Now, controller is a complex puppy. Be mindful, we are reaching a point where a single SSD can easily survive a speed of few gigabytes per second. So that's idiotically fast. That's so fast that back in the days, that would have been enough to handle whole of Facebook. That's how fast a single SSD can be nowadays. So you need a controller that is equally capable. Like, you do have controllers literally on SSD that have their own RAM, as in like 2 or 8 GB of RAM on SSD, and then they have their own cache memory, own quad core CPUs just to handle the system. So every company developed their own, be it Samsung, be it Kioxia, be it Western Digital. But Western Digital is like, hey, we are the signatory of ISA, Instruction Set Architecture of RISC-V. So what if we use that technology? We had the core level benefit. Core is already built. The foundation is solid. And so many people are testing it absolutely solid. And then they built on top of it. This is the puppy they built. SWERV core. This is what they're using right now. And this is Samsung. RISC-V using 5G. So that's the whole thing. Every company is pouring money into this. This is important. If you are, like, for example, if I'm an Indian company like Blue Star air condition, I would actually do it. Why? Everybody in the future wants their Internet of Things device. Everything requires insane amount of computer processing nowadays. Like, even air condition, back in the days, it was just like on, off, PWM, basically slow PWM. Nowadays, you have like literally graph cuts, basically temperature graph is going there, humidity graph is going there, power graph is going there, and in some countries, there is like, time graph going, the time graph, because again, if you have different electrical rate at different time, you want your compressor to run full power when it's cheap and not, again, yeah, those things are also happening. So all that data, that's a serious amount of computation power, specifically if you have what you call BLDC motor drivers or inverter drivers. Those require serious amount of computation. Instead of developing your or buying, what most companies do right now, they buy it from ARM. Instead of buying it from ARM, like ARM has sold around 200 billion, I'm not even joking, 200 billion microcontrollers. So let that sink in. In those sort of, in those contexts, you can be like, hey, instead of buying from ARM, I could, deploy RISC-V, and be mindful RISC-V is cheaper. Why? No license fee. It's happening right now. And if I were any company that's like actually developing hardware, any utensil, be it microwave to stabilizers to air condition, whatever have you, I'll pour a lot of money into basically have a section, just figure out RISC-V, because again, RISC-V allows you to scale without any limitation, and you can go up to a level where you can control your own silicon. So in the future's time, having in-house control of the silicon, basically how Apple becomes such a big deal, because again, they were controlling the silicon, is the next frontier of all product categories, be it motor drivers, be it televisions, be it, like again, even this TV has its own control, dedicated processor. That processor is still not LG's processor. This TV is LG, but processor is not. Processor is from ARM. So that's why this matters. Every company is pouring money into it. And again, we'll all benefit from it, ironically. So that's the one good thing about it. And companies that are like, sleeping over the wheel, ARM is there, ARM is there. They may wake up one day and it's like, ARM is no longer powerful enough. Like literally how Intel woke up one day, it's like, Apple just bitch slapped me. Same thing could happen to them. So this is a very serious race, like lot of money, serious amount of money being poured into it. So this was my presentation on basically RISC-V single board computer. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.